All right, let's dive into algebra. But wait, not that dry, dusty textbook kind you're probably thinking of. No, today we're going to look at algebra for what it really is, a powerful language for solving puzzles.
So what if you thought about math not just as numbers, but as a language, right? Imagine you're a detective, and algebra is your secret codebook. It gives you all the tools you need to crack any case, to break down a big mystery and find that one solution. Every single letter, every number, it's all part of the clue.
So let's get our hands dirty. Here's our first coded message. 5, open bracket, n plus 2, close bracket. See how it's all kind of bundled up and locked away? To figure out what it's really telling us, we're going to need our very first tool.
And here it is, tool number 1 in our toolkit, the unpacker. Its whole job is to open up these expressions that are trapped inside brackets. Now, the official term is expanding brackets, but let's be honest, unpacking just sounds way more fun, doesn't it?
Okay, but before we start unpacking, we should probably know what we're unpacking, right? It's something called an expression. Just think of it like a mathematical phrase, something like n minus 3. It's got numbers, it's got letters, but, and this is key, there's no equal sign. It's just a piece of the puzzle, not the final answer.
So, how does this unpacker actually work? Well, it's a pretty simple 4-step deal. First, you just find that number hanging out on the outside of the bracket. Then, you multiply it by the first thing inside. After that, you multiply it by the second thing inside. It's kind of like you're throwing a party, and the number outside is handing out snacks to everyone inside the bracket. Nobody gets left out. Let's see it in action.
Okay, we are back to our original puzzle, 5 times n plus 2. We've got the tool, we know the steps, let's do this.
So here's what happens. That 5 on the outside multiplies the n. Boom. Then, that same 5 multiplies the 2. See? Everything inside gets a piece of the action from the number on the outside.
And voila! The message is unpacked. It's decoded. 5 times n gives us 5n, and 5 times 2 is, of course, 10. So that whole thing, 5 times n plus 2, is really just a fancy way of saying 5n plus 10. Puzzle solved. We've made it way simpler.
Now, this brings us to a really, really important point. Look over here on the left. That's our expression, 5n plus 10. It's just a phrase. But on the right, that's an equation. And that equal sign, that little guy, changes everything. An equation is like a full sentence. It's making a claim that two things are exactly equal. And to solve that, well, we're going to need a whole new tool. So let's bring out tool number 2, the balancer. This one is all about solving equations. And the best way to think about it is to picture a perfectly balanced scale in your mind.
This right here, this is the golden rule of algebra. I mean it. If an equation is a balanced scale, then whatever you do to one side, you absolutely have to do to the other. You add something on the left, you add the same thing on the right. It is all about keeping that perfect balance. Don't tip the scales.
Okay, new puzzle on the board. We need to find x in this equation. 2x plus 3 equals 11. Our mission, should we choose to accept it, is to figure out the one single value for x that keeps this whole thing perfectly balanced.
All right, first move. We want to get that 2x all by itself. So that plus 3 has got to go. And how do we get rid of a plus 3? We do the opposite. We subtract 3. But remember the golden rule? To keep it balanced, we have to subtract 3 from the other side too. That leaves us with something much simpler, but still perfectly balanced. 2x equals 8.
We are so close. Now we have 2 x's, but we just want to know what 1 x is worth. So we have to cut that left side in half, right? We divide by 2. And if we do it to the left, we've got to do it to the right. 2x divided by 2 just leaves us with x, and 8 divided by 2 gives us 4.
And there you have it. The solution, x is 4. We just found the one single number in the entire universe that makes that original equation true. How cool is that? Okay, so far, so good. Our puzzles have had one clean, neat answer. For that last one, only the number 4 worked. But what if there isn't just one answer? What happens when the solution isn't a single point, but a whole range of numbers? What if you have boundaries instead of a single destination?
For that kind of problem, we need our third and final tool, the mapper. The mapper is all about helping us see the answers on a number line, which is basically a map for every possible number. This is how we're going to tackle something called inequalities.
So with inequalities, you don't have an equal sign. Instead, you've got these guys. They don't say two things are the same. They're all about saying one thing is less than another, or greater than another. Think of them as the directions for drawing on our number line map.
So here's how we actually map these solutions out. The shaded part, that's all the possible numbers that work as an answer. But you got to pay close attention to the circles at the ends. That's the really important detail. A filled-in circle means that number is included, it's part of the answer. But an open circle, like this one here at -2, means the answer gets super close to it, but never actually touches it. It's a boundary you just can't cross.
So let's just step back and look at the awesome toolkit we've just put together. You've got the unpacker for breaking open and simplifying expressions. You've got the balancer for finding that one precise answer to an equation. And you've got the mapper to draw a picture of a whole territory of answers for an inequality.
I mean, think about it. From decoding little messages, to finding exact values, to mapping out entire ranges of possibilities, these three tools are the real foundation for solving some incredibly complex problems. So the only question left is, now that you have the tools, what puzzles are you going to go solve?